Welcome to our next chapter. We've successfully gotten through chapter 4 with polynomials and our exponent rules. This chapter will explore all the different types of factoring those polynomials. So in most cases it will be a trinomial, but not in every circumstance. If there was one skill that the rest of our class depends on students mastering, it is this skill right here. So factoring plays a crucial role between now and the end of the course. Even when it leaves for a little while, we always circle back and you'll notice me say, okay, the next step is to factor. The next step is to factor. So it needs to become familiar to you to the point in which you just understand how to factor. The way multiply might come easily after doing it over and over and over again. So I would encourage you to watch tons of videos, do your homework, practice, practice, practice. Reach out to me, send me pictures on your phone of what you tried so I can make those corrections and help you to the best of my ability. So section 5.1, there's lots of different types of factoring. Section 5.1 explores 3 types of factoring. And the first type I have written right here, it's called the GCF. It stands for greatest common factor. And so what we're going to do is we're going to look first at our coefficients, and we're going to think to ourselves, what is the largest number that goes into all 3 of those coefficients evenly? And so maybe some of you are thinking, well, they're all even, so 2 divides into them. And let me show, yes, it's true, but it's not the biggest number. So let me show you how to know if you chose a number too small. So let's just pretend I pull a 2 out. Whatever that number is, you're going to put outside the parenthesis. All right? 2 goes into 12 6 times. 2 goes into 18 9 times. 2 goes into 24 12 times. And then we would mess around with the variables after that. Now, check out these coefficients. All 3 of those numbers are still divisible by 3. And so since these 3 numbers still have a common factor, 2 can't be the biggest factor that we would pick. And so if that helps at all, hopefully, we have to think of a number that's bigger. So the number is actually 6. 6 divides evenly into all 3 of those. And so I'm going to pull the 6 out front. Don't write that parenthesis quite yet. And then I'm going to look at my variables. So I'm going to look at the x. I have x to the 5th, x squared, and x to the 3rd. You want to pull out front the smallest exponent because it has to be something that's in all 3 terms. So the most I can bring out front is the smallest one I see. So that would be x squared. Now let's think about the y's. I have y, remember there's a little 1 right there, so I have y to the 1st, y to the 3rd, and I have no y's at all. Since this back term has no y's, we can't possibly pull a y out to the front because we can't divide that out because it doesn't exist back here. So if you can't pull it out of every term in your polynomial, you don't do anything with it. All right, so we're going to divide our coefficients, and we are going to subtract our exponents. And nothing is going to change with that variable y because we didn't do anything out here. So 6 goes into 12 twice. 5, take away 2 because I'm pulling it out. Think about it would be like if I'm doing this. I'm dividing it by 6x squared. So 12 divided by 6 is 2. And then 5 minus 2 is x to the 3rd. And the y doesn't cancel. So that is exactly what's going in right there. This is the math we're doing. You don't need to write that down for every term unless that's helpful for you, because we just care about what's left inside this parenthesis. Okay, So 6 goes into 18 3 times. Keep in mind it's going to be a negative. We have x squared and x squared, so 2 take away 2. We don't have any x's there at all. And then y to the third. 6 goes into 24 4 times. 3 take away 2 leaves 1. If there is 1, 2, 3 terms in your original problem, there should be 1, 2, 3 terms inside your parentheses. So keep that in mind as well. Let's do it again. In the book, you're going to see a lot of things that might look like this. So let's practice one like this. It's a little bit shorter, may or may not be easier for you. Between 14 and 7, you can take out a 7. Between y to the third and y to the first, we can bring out a y. Now we're going to divide and subtract. So 7 goes into 14 twice. 3 take away 1 leaves y squared. 7 divides into 7 once. Y squared, or y to the first minus, or 1 minus 1 is 0, or y to the first over y to the first just is 1 again. Okay, and so there's no y's here in the back, but the piece I want you to focus in on is that 1. So you still have 1, 2 terms in your problem, 1, 2 terms in your polynomial that's in your answer inside those parentheses. You just have this 1 as a placeholder. That was not my greatest way of explaining. Let's do one more here. And then we'll erase everything up here. Let's do negative 3 x squared minus 6x, and then maybe plus 10 x to the fourth. Okay. When our polynomial starts with a negative, let's take this off. So sorry. I don't want to confuse people that it's not in descending order, and that is not the main thing I want to show people anyways. And so when our polynomial begins with a negative number, oftentimes you will notice we factor out that negative, because what's left after we factor that out sometimes can be factorable, and that negative in front makes it difficult. Remember, that vocabulary word is called the leading coefficient. And so when I notice that it starts with a negative, oftentimes we pull that out front. I hate to say always, because later in the chapter there might be exceptions to that rule. All right, but we're going to factor out a minus 1. Now, between 3, 6, and 10, there are no common factors. There's no number that divides nicely into all of them. And so we have nothing there. We have x squared, x, and then no x in the back. So as a matter of fact, the only thing I'm really going to be able to factor out here is a negative 1. So that's going to leave me 3x squared. Keep in mind, when we factor out a negative, that will change that negative to a positive. And when I factor out that negative, it will change this one to a negative. Because the point being is that if you were going to multiply it back through, you would end up with what you started with. So for instance, if I took this problem right here that we just looked at, and I multiplied this through, I would end up with exactly my original question. So if I multiplied this negative here by this positive 6 here, it would end up being a negative 6 over again. There are problems where you can't factor anything. So I'm going off script here, but let's look at something like that. And this will pop up occasionally. And it usually is more confusing because you want something to factor, so then you'll go back and you'll stare at it, you'll say, why isn't this factoring? Why isn't this factoring? And it's because it's called prime. It cannot be factored. Think about what a prime number is. A prime number is the only factors are 1 and itself. So the only factors here are 1 and 5x plus 9. There's no other way to break that apart and have it be a multiplication type question with anything other than 1. All right, so there is GCF. There is greatest factoring using the greatest common factor. As we go through this chapter, this needs to be your number one skill you look for. We often say this is the first thing to look for. What is the first rule of factoring? Is there a GCF? Because oftentimes there will be a greatest common factor, and then what's left inside the parentheses can be factored some more. Not always, but often. So, the second type of factoring that is in section 5.1 is called grouping. So the second type we're going to look at, we have 3 skills in 5.1. So we're going to factor by grouping. How do you know? Because a lot of times I think when students learn factoring, when it's just that one thing, you got it. You're like, okay, I know how to use these steps. I know how to use these steps. But when you throw it all together, then it's like, I don't know when to use which method. You will 100% know it is grouping. I hope I can stand by that. Most often it is grouping when it is for terms. So bear with me on some of my mistakes. I'm still not maybe the perfect video teacher quite yet. I've had to really overcome a lot to be able to do my lessons on video. Being on camera used to be one of my, kind of like my inner fears. So forgive me if I occasionally say the wrong thing. So here's our first example. Grouping 4 terms. The idea behind grouping is this. You're going to make sure it's in descending order. And you're going to take the GCF here. And you're going to take the GCF here. So what is the greatest common factor in these 2 terms? What is the greatest common factor in the last 2? So between 5 and 1, we can't pull out a coefficient. But between x to the 3rd and x squared, I can pull out an x squared. I can pull out that smaller exponent. What's left? Well, this is a 1 right here. I bet you in my math lab, you never type that in, but there is that 1 right there. And so we have the 5 still here. 3 take away 2 is x to the 1st, minus this is this. So we need a 1 as a placeholder. Plus, because this is a plus. What is the GCF between 15 and 3? It's a 3. In parentheses, 3 divides into 15 5 times. 3 goes into -3, -1 times. Check out what just happened. 5x minus 1, 5x minus 1. 100% of the time, you want those to match. And when they match, here's what you do. You write this as its own parenthesis. So you're going to have x squared plus 3, and then behind it, 5x minus 1. Now, technically it doesn't matter which order you write these factors in. It's just like how 2 times 3 is the same as 3 times 2. It doesn't matter at all. All right, So that's grouping. Does it get harder? Occasionally it might seem harder, but this is the gist of it. So let's go through it 2 more times. Let's try this one. If you think you've got it, you can even pause the video and try this one on your own. Every example we do is going to have a little bit of a twist to it, so I can kind of show you a variety of types of problems. So we're going to GCF, and then we're going to GCF. All right. In the first 2 terms, it looks like I can pull out a 2 and an x squared. I'm going to be left with x, because 2 divides into 2 once. 3 minus 2 is 1, plus 2 goes into 8 4 times, and then this is this, so there's nothing in the back. In the back here, between x and 4, there's nothing. But remember the goal. We want those parentheses to match, and so we want to have that x plus 4 right here, because then those guys would match up. And we want these 2 things to be able to go in its own parenthesis. And so since there's nothing that goes into the back, we're going to put a placeholder right there. And so then my final answer would be 2x squared plus 1, and then x plus 4. Next one. What happens if you have a problem? Oh, I'm a liar. I have 2 more. All right. What happens if you have a problem like this? And again, the steps are more or less the same, but sometimes the book, your teacher, a test will give it to you in a tricky way. So kind of take a second and look at that and tell me or think about what we should do before we get started. And hopefully you can see that your exponents are not in descending order. So I would rewrite, and it'll make the process easier. And then you might even want to see how far you get with this one. Maybe pause. There is a little bit of a trick to this one, and I'll show you in just a second. So we're going to GCF. We're going to GCF. We're going to take out a 4t squared, and we're going to be left with t plus 5. And then we see these 2 right here. And so now, here's the part that's a little bit tricky. This is a plus, but this is a minus. So when I pull, there's a 3 that goes into both of those numbers. When I pull that 3 out right here, if I make it a -3, if I divide -3 into -15, it's going to change this to a plus. And now I have what I desire, which is those 2 parentheses matching. And so then I can write this in the front and that, and then the t plus 5 in the back. All right, let me just double check there. I think that'll cover everything. If you would like to try one, I didn't give you a GCF one to try, but we can stop and try this one. So if you don't feel like you need to try, go ahead and fast forward to the next section. Let's do 3x to the 3rd minus 3x squared plus 2x minus 2. It's in descending order, so I didn't want to trick you there. so you can go ahead and try that. So in our first two, our GCF is 3x squared. So we have x minus 1. In our second two, our GCF is just a 2, but there's already a negative here to match. So if I pull the 2 out front here, I can go ahead and keep that positive because this negative will match that negative. And so then 3x squared plus 2 and x minus 1. And I just turned the page and I'm seeing in my notebook that this completes 5.1. So you're good on that, and I will keep going with 5.2 on a different video. So have a good day, class, and I'll see you soon.